Welcome back, guys. Today we'll be doing error between a line and a curve. This is coming from a CAPE Mathematics 2007 paper. Now, finding the error between a line and a curve. So I'm going to read the question. In the diagram below, not drawn to scale, the line y equal 2x plus 3 cuts the curve y equal x squared at the points P and Q. So this is the line y equal 2x plus 3, and this is a curve x squared. We're trying to find first the coordinates of P and Q, which is a point of intersection for the line and the curve. So I need to find the point of intersection for P and Q, where I'll find the coordinates. When we are talking about intersection, we equate the equations to be equal. So I'm going to equate x squared to be equal to 2x plus 3. Then I'll carry the variable 2x and positive 3 over the equal sign, but I could have done it the other way. So I'm carrying 2x and positive 3 over the equal sign, so both of them become negative. So I have minus 2x, and the plus 3 now becomes negative 3. And now what is left on the right is equal 0. Now I'm going to factorize. So I need to find two numbers that multiply to give me negative 3. So let me go ahead and write it. And we need two numbers that add to give me the coefficient of x, which is negative 2. So the number is negative 3 and positive 1, because negative 3 times 1, that's negative 3, and negative 3 plus 1 gives me negative 2. So now that we have the factors, we're going to substitute the center with the factors. So I have x squared, and now I attach an x to this, so I have minus 3x. Now you can either have plus x or plus 1x, whichever one you're comfortable with. Minus 3 equals 0. Now I'm going to group, so I have them in two different groups. Then I look at the first bracket and I see what can I factor out of the first bracket. I can factor out an x, so what is left? Now, remember when you're factoring out, or you can review my factorization of quadratics. So you factor out an x, so you're left with just x. Then you factor out another x, so we're just left with minus 3. Within the second bracket, when we don't have anything to factor out, you factor out the 1. That's why I have the 1 in front to show you that whenever you don't have something similar to factor, you can factor a positive 1, but if it was minus x, then you'd factor out negative 1. So factoring out positive 1 doesn't change anything, so we're left with the same thing in the bracket, which is x minus 3, and we have it equal 0. So I'll have x plus 1 in one bracket, and then I'll have x minus 3, but we're solving, so what's going to happen is that I'll have to equate each of them to be equal to 0. So let me go ahead and write the x plus 1, and beside it you'll have x minus 3, and then we'll have it equal 0. Now, equating each of them to be equal to 0, because we're trying to find the x value, so carrying the plus 1 over the equal sign becomes negative 1. Same case here, I have x minus 3 equals 0. So carry the minus 3 over the equal sign, so we have x equal to positive 3. Now we want coordinates. This is just the x value. When we say coordinates, we want x and y values. So what we can do to get the y values is to go ahead and use either the function y equal x squared or the function y equal 2x plus 3. For me, I'm going to use y equal x squared to find what is the y value. So first I'm going to find y when x is equal to -1. So substituting into the function y equal x squared, replace x with -1. Now I like to use brackets because sometimes students forget that it is the negative sign is being squared also, so it becomes +1. So the first set of coordinates is -1 and 1. Now I'm going to test when x is 3. So again, I'm using the same function. You could have used a line, but I'm using the same function. Y equal x squared. So replacing x with 3. So we're going to square the 3. So 3 squared is 9. So the coordinate for this is x is 3 and y is 9. That's it. So the next thing is to assign the coordinates to be P and Q. P has to be -1 and 1 because x is a negative number. So it has to be P. So it means that this is P just because x is a negative number and where it's positioned on the graph. So that means Q is a +3 because it's on the positive side of the x-axis. And that's it. That's all we know, which is P and Q. So now we're going to find the area between the line and the curve. We're asked to find the area of the shaded region, which is a section POQ. Now, what we're going to do, we're going to find the area, but first, let me just remind you the x values for P and Q. That's what we're going to use here. So we have to find the area below the line minus the area below the curve, and that will give us a shaded region. So some persons like to find the area of the curve separate and the area underneath the line separate, then subtract. That's fine, but I'm just going to combine. So have my limits, -1 and 3. That's the region we're integrating. Then we have the line first. So we have 2x plus 3 because that's the one above, the one that is above. That's the one you write first. Minus the curve, which is below it. Now it's with respect to x, so that's why we have dx. So integrating 2x, just a reminder of the formula to integrate 2x. It is x to the n. So once you're integrating something to the power n, it's equal to x to the n plus 1 over n plus 1. So 2x, remember that 2x means x is raised to a power. So the power here is 1. So integrating this, I am going to have 2x to the power 1 plus 1 all over 1 plus 1. So I'm going to have 2x squared all over 2, then cancel this, so I have just x squared. So the integral of 3 is just 3x, so you just attach an x to the constant. And then we're going to integrate minus x squared, so you're going to do the same thing as what I did before, where you add 1 to the 2, so it becomes 3 over 3 plus my constant. Now I'm going to have the upper limit and the lower limit. Now I'm going to substitute the limits. So I have the upper limit first. So I replace x. So I have 3 squared plus 3 times 3 minus, that's going to be 3 cubed over 3 plus the constant, and that is the upper limit. Then you minus, substituting the lower limit. So we're going to have negative 1 squared, but this part I'm going to put in bracket. So you have negative 1 squared plus 3 times negative 1 minus negative 1 cube all over 3 plus constant. Now to work out what I have here, so I have the upper limit that I'm going to simplify. So I'm going to calculate 3 squared is 9, 3 threes, 9, and 3 cubed is 27, but we divide by 3 is 9, plus c. Now this cancels, so I just go ahead and cancel it. So for the upper limit, I'm left with 9 plus c. In the lower limit, negative 1 squared is positive 1. Positive 3 times negative 1 is negative 3. And negative 1 cubed, that's negative 1. But the minus sign in front, change it to positive 1 over 3 plus c. Now there's a negative sign in front of the square bracket, so it's going to affect what's inside. So this becomes negative 1, positive 3, then this changes to negative a third, minus c. So this cancels. 9 minus 1, that's 8, plus 3, that's 11, minus a third, that is 10, and 2 over 3. Error, we have to write square units, because I don't know what's the unit, but it's square units, and that's the answer. And that's it. The error between the line and the curve is 10 and 2 over 3, or some persons will say 10.67 square units. That's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel, and if you have more questions, you can leave a comment below and I'm sure to answer it.